Depending on local conditions, they may change hydrology, temperature, and water and soil chemistry. Overall, beavers tend to increase habitat and species diversity at the landscape scale. As the habitat is altered, interactions amongst cohabiting species may change. For example, brown trout or brook trout, char, may become dominant over Atlantic salmon. In addition, both inhabited and abandoned or collapsed dams have a major impact on local vegetation and the succession of plants, as well as on a wide range of animal, reptile, and bird species. The dams require continuous supervision and perpetual labor, wrote Lewis Henry Morgan. The effects of water percolation, seepage, settling, and decay demand careful vigilance and repair. In fall, the beavers add a new supply of materials to the dams to compensate for decay, using wood cuttings from the previous autumn that they have stripped of bark for food and purposely laid aside for use in the repair. Dams may fail for a number of reasons, including floods, animals burrowing through them, and the collapse of dams upstream. Many humans look on beavers as pests and try to destroy their dams, but even when a dam is dynamited, the beaver family works hard and fast to repair it. Sometimes, with a fairly new dam, the beaver colony will move, but only to the next strategic location up or down the river or ditch. Whether beavers repair a broken dam depends on the season and on the size of the break. The more effective way to eradicate beavers is to kill or destroy young willow or cottonwood trees near their dams. These trees provide the beavers basic food and construction material. They can repair a dam, but they cannot replant trees. This might seem an obvious point, but it shows that there is a limit to how far beavers will go down the chains of consequences and put problems right. Humans follow further along the chains of consequences. China's Three Gorges Dam on the Yangtze River is the largest dam made by humans. It is nearly 1.5 miles across, produces 18,200 megawatts of hydropower, cost between $25 billion and $40 billion, and displaced 1.6 million people. It provides considerable benefits in electricity generation, irrigation, and flood control, as well as to the pocketbooks of politicians, bureaucrats, and construction companies. But the chains of consequences are often very negative. For example, the Three Gorges Reservoir was in 2008 described as a cesspool because of the hundreds of factories, mines, and waste dumps that were inundated by its creation. The rising reservoir set off landslides, forcing communities to relocate. Even at the mouth of the Yangtze, hundreds of miles downstream, salt water moved up the river as the flow of fresh water declined, and as a result, tidal wetlands near the mouth deteriorated. The impacts have also been cultural. Many archaeological and cultural sites were threatened by the Three Gorges inundation, but archaeologists were able to investigate some 1,087 sites throughout the valley, gaining information about people who lived there as much as 2 million years ago, as well as for nearly every era of habitation since. But untold information was lost to the rising water levels. Saving the more important sites involved costly interventions. The Baihuliang stone, the best-preserved ancient hydraulic station in the world, was saved by constructing an underwater museum around it. Shibujai, an ancient Buddhist temple built by the Ming Emperor Wanli, is now an island in the center of the new lake, surrounded by a concrete dike. Some structures were moved altogether, such as the Zhongfei Temple, which was taken down one brick at a time and reassembled at a higher elevation. The damming of the Nile brought similar consequences. From the time of the earliest